Alright, so in this video, we will continue with topic 2.2, variation of pressure vertically in a fluid under gravity, and we also compare it with the horizontal cylinder under gravity. So first, let's look at this figure here. So you have a vertical cylinder, which is surrounded with the same fluid of mass density rho. And in this cylinder, there's a pressure at the bottom of the cylinder, P1, okay, at level Z1, and there's another force acting on the top of the surface, which is P2, pressure 2, multiplied by area, and it is at Z2 height, level Z2. So the fluid is at rest and it is equilibrium, so all the forces in the vertical direction sum up to 0. So yes, Fz is equal to 0. So you actually not only have two forces, but keep in mind that for vertical direction, you always have W. Okay, because we are at the earth now. So you cannot neglect the gravitational force of this cylinder. So the first one acting are force due to P1 on area A, okay, and then another force due to P2, and last one is your weight. Okay, so as you know, weight, okay, as we have learned in chapter 1, weight is equal to mass times gravitational force, and your mass, okay, you need to relate your mass with the density formula, where mass density is equal to mass over volume. So your mass is actually density multiplied by volume multiplied by gravitational. Okay, the density is mass times volume, and here you have gravitational, and you can get your W. So if we relate this volume with the cylinder, okay, it is actually rho multiplied by area. Okay, the volume is equal to area times this circle area multiplied by the height, which in this case is Z2 minus Z1. Okay, because we only want this height, the height of the cylinder. Okay, multiplied by G to get your W. Okay, so if you do the force balance on Z direction, okay, so first you have one force acting upward, which is positive. So P1A minus P2A, one on the top, and the other one is your weight, rho G A Z2 minus Z1 equal to 0. Okay, you have three forces here. So since you have A in all the terms, you can cancel out A. So P1 minus P2 is equal to rho G Z2 minus Z1. Okay, here P1 minus 2 is delta P. Okay, P2 minus P1 is delta P. So this term must be negative. Rho G Z2 minus Z1. So this is the final equation that we are interested in. Because from this equation, we can conclude that in any fluid under gravitational attraction, pressure decreases with the increase of height Z. So as you also have learned in thermodynamics, so if you compare the pressure on top of Mount Everest compared to Mount Kinabalu, so you are, based on your calculation, you can see that at Mount Everest, your pressure is lower compared to at the top of the Mount Kinabalu. Okay. So now let's look at this diagram. So what if you have a horizontal cylinder? So here you have a pressure exerted on the left side positive, and also another one exerted on the right side. So this side is negative sign, and then the other force, this is compulsory, okay, acting vertically, your weight. So if you do a force balance on the x direction, okay, so you will get P1A minus P2A is equal to 0. So rearrange this equation. Okay, A can cancel out, so P1 equals to P2, which tells us that pressure in the horizontal direction is constant. Okay, and here, the figure at the bottom here, you have two tubes that is connected with a pipe, but this tube, one has smaller area and the other one has a bigger area. Okay, what we want to argue now, is it true for two connected tanks which appear not to have any direct connection, for example below, can we have the pressure in horizontal? We want to see if the pressure is constant or not. Okay, so now let's see here. So on your left side is P, and on your right side is tank Q. So for PL is equal to PP plus rho GZ. And for your PR here, you have PQ plus rho GZ. So if we arrange this, okay, you will get PP plus P rho GZ equal to PQ plus rho GZ. So rho GZ cancel out. So your pressure at this point and at your PQ are the same. So pressure at two equal levels with both tank at the same height. Okay, the pressure at P and Q are the same. Okay, so that's all in this video. We will continue the next topic in another video. Thank you.